Hello everyone, today in this video I will discuss basics of flip-flop, register, counter, memory, flip-flop. A flip-flop is a basic element in sequential logic circuit. A flip-flop is essentially a 1-bit memory element because it can store 1 bit, either 0 or 1. A flip-flop is also known as bistable multivibrator because it has 2 stable states. The following are the various types of flip-flops: RS flip-flop, clocked RS flip-flop, JK flip-flop, master-slave flip-flop, D flip-flop, register. A register is a group of flip-flops. A flip-flop can store 1-bit information. So, an n-bit register has a group of n flip-flops and is capable of storing any binary information containing n bits. The 2 basic functional characteristics of a register are temporary storage, shifting capability. Counter. A counter is a register capable of counting the number of clock pulses applying at its clock input. The counters are mostly constructed using JK flip-flops in toggle mode, or T flip-flops. 2 types of counters are available: asynchronous, or serial; synchronous, or parallel. Memory. Data storage devices are an essential requirement of computer systems, and many other electronic devices depend on memories for their functioning. Memories are required to store data as well as to make it available for processing as and when required. A device that stores information in electrical, magnetic, or optical form is known as memory. Data are stored in a memory by a process called writing and are retrieved from the memory by a process called reading. This image for general idea about types of memories. Semiconductor memories. Semiconductor memories refer to memory technologies that use semiconductor materials, such as silicon, to store digital data as electrical charge, making them fast, reliable, and ideal for various applications in modern electronics. Magnetic memories. Magnetic memories involve memory technologies that use magnetic materials to store data as magnetic fields, offering non-volatility and higher data retention, commonly used in magnetic storage devices like hard disk drives. Static RAM, SRAM. SRAM is a type of RAM that uses bistable flip-flops to store each bit of data, providing faster access times and lower power consumption compared to dynamic RAM. SRAM does not require periodic refreshing, as it can maintain data as long as power is supplied, making it ideal for cache memory and high-performance applications. Dynamic RAM, DRAM. DRAM is a type of RAM that uses capacitors to store data as charge, which requires periodic refreshing to maintain the stored information. DRAM offers higher memory density at a lower cost compared to SRAM but has slower access times and higher power consumption, making it suitable for main memory, RAM, in computers and other devices. RAM. Volatility. RAM is volatile memory, which means it loses its data when the power is turned off or during a system restart. Read and write operations. RAM allows both read and write operations, making it suitable for storing temporary data and executing programs. Data access speed. RAM provides fast access times, enabling the CPU to quickly retrieve and manipulate data during program execution. Usage. RAM is used as the main memory in computers, smartphones, and other devices, providing a workspace for running applications and storing data in real time. Refreshing. Dynamic RAM, DRAM, a type of RAM, requires periodic refreshing to maintain data integrity due to the nature of its storage technology. ROM. Non-volatility. ROM is non-volatile memory, meaning it retains its data even when the power is turned off, making it suitable for permanently storing essential instructions and data. Read-only operations. ROM allows read-only operations, meaning the data cannot be modified or written by the end user after the manufacturing process. Data access speed. ROM generally provides slower access times compared to RAM since it is used for reading data rather than actively manipulating it. Usage. ROM is used to store the firmware, BIOS, bootloaders, and other critical instructions needed to start up and operate the computer or electronic device. Types. There are various types of ROM, including mask ROM, pre-programmed during manufacturing, PROM, programmable once by the user, EPROM, erasable and reprogrammable using UV light, and EEPROM, electrically erasable and reprogrammable. Bipolar ROM. Bipolar ROM is based on bipolar transistor technology. It provides faster access times but consumes more power compared to MOS ROM. MOS ROM. MOS ROM is based on metal oxide semiconductor, MOS, transistor technology. It offers lower power consumption but typically has slower access times compared to bipolar ROM. PROM, Programmable Read-Only Memory. PROM is a programmable memory chip that can be written or programmed once by the end user with specific data, but the stored data cannot be modified or erased after programming. Mask ROM, Read-Only Memory. Mask ROM is a non-programmable memory chip where the data is permanently written during the manufacturing process and cannot be modified or erased by the end user. EEPROM, Electrically Erasable Programmable Read-Only Memory. EEPROM is a programmable memory chip that can store and erase data electronically, allowing data to be modified and updated without the need for ultraviolet light or complete erasure. UVEPROM, Ultraviolet Erasable Programmable Read-Only Memory. UVEPROM is a type of programmable memory that can be erased and reprogrammed using ultraviolet light, allowing data to be modified multiple times. Summary points. Flip-flop. A flip-flop is a basic digital circuit element used to store a single binary bit of data, which can be in one of two stable states, 0 or 1, forming the building block for sequential logic circuits. Register. A register is a group of flip-flops used to store multiple binary bits of data simultaneously, serving as temporary storage during processing or for data transfer in digital systems. Counter. A counter is a digital circuit that counts clock pulses or events, capable of incrementing or decrementing a binary number in a predefined sequence, often used for timing and control purposes. Memory. Memory refers to electronic components used for data storage in digital systems, categorized into different types like RAM and ROM, crucial for storing data and program instructions in computers and electronic devices. Thanks for watching, happy learning. If we don't save trees, billionaires will sell oxygen. Sun Wheel Academy content is prepared by Chakra.